Okay, here we go with quite a large looking question. Okay, the context is species of orchids, and we're interested in how many orchids, the population will be how many of them there are at time t, and we've got this complicated looking expression that tells us how p varies. And we know 300 orchids when the study started. So we've got to decode this. 300 is a value for what? Well, it's how many there are. So that's telling us what p equals. And when the study is started, it's telling us the value of what t equals. So I've got a pair of values, p and t. I know the value of p for a particular value of t. Okay, and I need to be using that to find out what a is. It's a show that question, so I'm going to be ending with a equals 0.12. Okay, so how can I use these values to find out what a is? Well, p, I've got a value for p, equals, I'm going to have 2,800 times a times, well, I can work out what this is. I've got a value for t, so I'm going to have another number that I know there, and on the bottom I'm going to have 1 plus, again, a, times another thing that I know. So I've got a number that I know over here. Okay, so I've got something times a on the top of the fraction. I've got 1 plus something times a on the bottom of the fraction. These might not be very nice numbers, but I don't care. So I'm going to get whatever this number is here, times the bracket of 1 plus a times another number, equals, okay, well, 2,800 times this number is just a number. It's going to be a number times a. All right, so what I have to do is I have to put up with the fact that these numbers in these brackets may be horrible decimals. I'm going to get a number plus, multiply that by that, I'm going to have a number times a, equals another number times a. Okay, and then I'm going to take this away from both sides to get a number equals some number here times a. Now, if it looks scary because the numbers are decimals, just think how you would solve it if this was 5 plus 2a equals 7a. Okay? Well, you'd take the 2a away from the 7a and get 5a over here, and you'd have 5 here, and then you divide by this 5 to get the a equals 1. Your numbers will be nastier than 5 and 2 and 7, but the process of solving is exactly the same. And look, you know what the answer is going to be, so you should be all right. Okay, now the next part of the question, this is a re-entry point because look, we have a value for a, and we are predicting the number of years before the population of orchids reaches 1,850. So this is the population of orchids, so this is a value of p. Okay, so I'm going to substitute in for p. Okay, I can substitute in for a. All right, that all looks good. But now I need to find t. And once again, a bit like with a in the last bit, t is appearing in this term here. In fact, this e to the 0.2t, you might want to call that by a different letter. Okay, we now have a number times the unknown e to the 0.2t here, and 1 plus another number times e to the 0.2t here, and we've got a number over here. So we're going to do very similarly to last time. Okay, so let's think about that. P is just a number, put a bracket for that, equals 2,800 times a. We know the value of a. So that's just going to be a number times e to the 0.2t. And on the bottom of the fraction, we've got 1 plus a. We know the answer to that is just a number times e to the 0.2t. You can, if you wish, replace e to the 0.2t by another letter, call it y. So I might do that. I might say that the number I've got here is something times y over 1 plus something else times y. Multiply both sides by the 1 plus something else times y equals something times y. Okay. Multiply all of this out. We've got a number plus a number times y equals a number times y. Subtract this term from both sides, and we're going to be able to solve for y. Do not be put off if the things in the brackets are unpleasant decimals. Should be all right. Okay, now we're on to part C. Now this may look a little bit unexpected. In fact, this is yet another re-entry point. We're going to be using this value of a equals this. But what this is saying, this has got an unknown p and an unknown t. It's not related to the particular case we looked at in B. It's actually taking this equation and the value of a we've got and saying this equation is the same as this one. Okay, but what's different is instead of having 0.2 e to 0.2t on the top and the bottom, Okay, I've got no e's on the top, and on the bottom this has now become e to the power of minus 0.2t. So the kind of transformation that's happened in this fraction, okay, well, this may help without me actually doing it for you. If I start with something with, say, 7x on the top and something like 1 plus 2x on the bottom, how can I get from that to a fraction that's just got a number like 7 on the top and has just got a 2 here? Well, what I'd have to be doing is dividing top and bottom by x, okay? But I obviously can't just cancel these x's. Something's got to happen to this as well. I've got to divide the whole of the top and the whole of the bottom by x. So this one here, I've got to divide that by x as well. So I could say that's 1 over x. Or I could say, hey, 1 over x is x to the power minus 1, okay? So, in fact, this would be a correct transformation. You could look at this as just being multiplying the top and the bottom by x to the power minus 1, which makes this x go away, it makes this x go away, and it makes this one become x to the power of minus 1. So I think that will get you some of the way here. You will have values substituted in. This 2,800 times a will be a number which may be not dissimilar from 336, because this a here is definitely 0.12. So I think the same idea that we just talked about with the x's, instead of having an x, we've got e to a power. Okay, so if I had e to the power of, say, x here, that's not quite what you've got, and I had e to the power of x here, how could I get rid of these e to the x's? Well, I can multiply top and bottom by e to the minus x. So if I've got e to the x and I multiply that by e to the minus x on the top, then I've got to do the same thing. My 1 plus 2e to the x, I've got to multiply by e to the minus x on the bottom, okay? And these are going to cancel each other out. And these, in this term, these are going to cancel each other out, but I'm going to be left with an e to the minus x term. Now, obviously, you haven't got a 7 and a 2, and it's not quite e to the x you've got, but that kind of principle is how you can turn something like that into something like this. So I hope that helps. And then finally, hence show the population cannot exceed 2,800. So this, we've got to think about what happens with this function. Okay, well, we've got 336 on the top. Okay, and then we need to think about what kind of values this thing on the bottom can take. So this is 0.12 plus a power of e. So you need to focus, I think, on this e to the power of minus 0.2t. Okay, and you might want to sketch the graph of this, or you might want to just use your knowledge of what e to any power has got to be greater than. So there's a value that you can say that e to the power of minus 0.2t is always greater than that value, which will enable you to say that the whole of the bottom of this fraction is greater than a particular value. But that's on the bottom of the fraction. So 336 divided by what's on the bottom is then going to be, instead of greater than something, is less than something. So you're going to be able to argue that 336 over your 0.12 plus e to the minus 0.2t is going to have to be less than that critical value. And I'd be very, very surprised if that critical value was not, in fact, 2,800. So you've just, for these 2 marks, got to be fairly convincing about the way you explain that. I hope that helps.